We are starting the next topic, which is arithmetic sequences. So we're going to fill in the blank on this. A sequence is an ordered list of numbers. Each number in a sequence is called a term. So this here is an example of a sequence. So 3, 5, 7, 9. So this is a pattern of some sort. And we can continue this pattern on. We can also write a rule down for this pattern to find any term we want. So this says first term. So the way that we can identify this is using A for arithmetic and 1 for the term number. We are going to use what's called subscripts. So this is a subscript, A1. Superscript is like an exponent. Subscript is down below. It's like in the basement. So A1 is 3. And what this means is our first term is 3. A stands for arithmetic. 1 stands for the term number. Second term, third term, fourth term. So we can write these by just identifying the term number and what the term actually is. So A2 equals 5. A3 equals 7. A4 equals 9. The 3 dots means goes on forever. It's infinite. Okay. So what if we wanted to find A5, the next term of the sequence? What we would need to do is we need to look at what's the pattern. How is it going from 3 to 5? Plus 2. Which these do come out to be the odd numbers. You're right. 5 to 7 plus 2. 7 to 9 plus 2. So to find the next term, just going to add 2. It's 11. So 11 is the next term. So I'm going to put it down here. A5 is 11. So that is one way to identify the sequence. We can just look at the numbers, then we can write it as our term number. We can also write it as an input-output table where we have n, term n meaning number, term n, and then our y value, our output, is the actual term. For arithmetic. So whenever we get to geometric sequences, it'll be a G. But we're still using n as your term number. So our first term, term n, like A1, is 3. A2, so our second term when n is 2, it's 5. The third term is 7. The fourth term is 9. We could continue this table on and on forever, but we're just going to leave it like that. What we can do is we can use this sequence and write a rule for the pattern. So yeah, the pattern is plus 2, plus 2, plus 2. But what if I want to find the 50th term? What you would have to do is keep on adding 2. Or you could find the rule, which is kind of like an equation, to find the 50th term. So here is the formula in order to find the rule. So AN stands for the nth term, like the 5th term, the 50th term, whatever the term number is. So in this case, it'd be like A1. And then A1, that comes from our very first term. And the first term we're talking about is of the sequence. The first number that's listed in the sequence. And then N is whatever is here. Like if it's 50, then we put in 50 here. This is like matching, like f of x, and we have x, then match. Those numbers will match each other. And then D is the common difference or the pattern. So usually whenever you look at sequences, you can find out what the pattern is, how it's going from one to the next to the next. We're going to write the formula for this sequence so we can find the 50th term. So it's going to be AN equals, what's our first term?
A1.
And A1 is 3 over here.
Oh.
Yep. So 3 plus, I'm going to keep in, that's like my x value. Put it away. N minus 1. D, what's my common difference or pattern on this one?
2.
2, yeah. So I'm going to put over here D equals 2. That's what the pattern is. So I'm going to put it right here.
So for that N, why don't we do the number that we want to find out, like 50?
Right. So yeah, we can plug in. So let's do A50 equals 3 plus 50 minus 1 times 2. So let's clear out. Let's go back to the home screen. We can just use the calculator straight up. Second quit to get back to the home screen. So we're going to do 3 plus parentheses 50 minus 1 is 49 times 2. You can put in 50 minus 1, or to save yourself a step, you just write 49. 101?
101.
Okay, so the 50th term is 101. So how I showed y'all to put numbers into y equals to find the input output, you can do the same thing here. So I'm going to put this in. So go to y equals, clear out what's in there, and let's put in this equation. 3 plus parentheses. Instead of writing n, I'm going to use x. I can interchange my variables. So that'll be x minus 1, close parentheses, times 2. So even though there's nothing there, we know it's a multiplication. So second graph for the table. And we can look at, I'm going to go up. Oh, no, I'm going the wrong way. I want to go to table set, make this easier. I'm going to hit 0. No, I want 1. Table set start at 1. So I went second window to get to this page. Table start is 1. Go back to your table. And what we can do is we can look at the table and our pattern 3, 5, 7, 9, 11, 13, 15. So it's pretty cool how we can find our sequence using an equation and then putting it into y equals to look at our table. So we could make sure that 50 is right by doing table set, second table set. Let's start it with 50 instead of just scrolling all the way to 50. And then look at our table. 50 is 101. Is that what we got? Yep. So we did it right. It's pretty cool. Okay, let's look at part B. It says, in an arithmetic sequence, each term is found by adding or subtracting the same number to the previous term. So think about arithmetic. That is what you first learned after you learned your numbers. You started doing just basic addition and subtraction. That's arithmetic. So whenever I say arithmetic sequence, it's the pattern is a basic addition or subtraction. So I'm going to write that. Basic addition or subtraction is used to make the arithmetic sequence. So we have an example, 2, 4, 6, 8. What is the pattern on this sequence? 2 to 4 to 4 to 6. What is it? Plus 2. So that's your common difference. So you can write D equals 2. And to write the formula, we would need to know also what the first term is. What is A1? No, on this one, we're on a different sequence. It's 2. So we can write our sequence formula like this. AN equals A1, which is our first term, 2, plus parentheses N minus 1 times D, 2, times 2. So whenever you write your formula, we're going to plug in A1 and D to write our formula. We'll leave AN and N just like they are with the N. Okay, so we can leave it just like this. What you're going to learn in a minute is that we can actually simplify this to make it in simpler form. So we'll look at that in a minute. All right, let's go on to the next slide or the next page on here. Arithmetic sequence. Find the missing terms in the sequence. Are the sequences arithmetic? So what I want you to do with your group is do 1, 2, and 3. So let's look at our sequence. So let's look at the first one. What is the common difference?
5 or 10, I mean.
Plus 10. So then if that's the case, then our next term
Would be
45.
Oh,
Then what's our next term on there? The missing 75.
oh,
Good.
sorry.
Is this arithmetic?
Yes.
Yeah, because it follows a common difference. D equals 10. It's adding 10. Okay, let's look at the next one. Number 2, what is the common difference? Minus 3. Is that happening every single time? Okay, so what's the next one?
-9.
-9. And then what's the next one? -12. Good. So is this arithmetic?
Yes.
And yes, because our common difference is -3. Okay, this last one, what is that?
That's 5.
+5. Is this also +5?
No, plus 7.
+7.
Plus 9.
+9.
Plus 11.
Oh, okay. What is this?
35.
Okay. And then
Plus 13. Plus 16. Plus 17. Plus.
okay. Okay, so is this arithmetic?
No.
No, we don't have the same common difference. It's different. So different. It doesn't have a common difference. Okay, let's look at the next one. Find a formula for each arithmetic sequence. So here are the steps over here. This is important. So number 1 says find the common difference. So let's look at 3, 6, 9, 12, 15. Common difference? 3 to 6 plus 3, 6 to 9, 9 to 12, 12 to 15. Okay, so our common difference, D, is +3. So we'll just put 3 there. So we did step 1. Step 2, look at the first number in the sequence and plug it in for A1. What is A1? A1 is also 3. It's not always going to happen like that. And then it says plug it into plug in. So we need to know our formula. So I'm going to rewrite my formula here. AN equals A1 plus parentheses N minus 1 times D. So let's write. We're going to plug in a number for A1 and D. So AN equals A1 is 3 plus parentheses N minus 1 parentheses times D. So times 3. I'm just going to put a little dot, or you can put it in parentheses. If it's a negative, you definitely want to put it in parentheses because that can get confusing. So then it says 3, distribute. What are you going to distribute? I don't see where it's distributed.
We distributed that 3 from the other side. Yeah, the 3 at the end.
Yeah, we're going to do like this. So we have AN equals 3 plus 3 times N, 3N, 3 times a negative 1.
-3.
3. Okay. So we distributed. Part 4 is combine like terms. So what terms will you combine?
3 and -3.
Yeah, what happens with 3 and -3?
Zero.
So it's just AN equals 3N. Would that make sense with this? 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9.
Yes.
3 times 4 is 12. So it's multiples of 3. 3n can get you multiples of 3. All right, we will finish the next one tomorrow. So no homework tonight.
Yay.